Welcome to Lecture 9 of Anthropology 330, Hunters and Gatherers. This lecture covers the chapter by Mythen on the ethnography of hunter-gatherer decision-making. In this lecture, we'll look more closely at the kinds of information foragers use to locate and acquire plant and animal resources, as well as the methods they use to acquire that information. One of the reasons human resource extraction techniques are considered to be complex is that they're information-intensive. That is, many of the foraging techniques humans use require a lot of skill and knowledge and take a long time to learn. Compared to other species, humans acquire and utilize a much greater quantity and variety of information, exchange a much greater quantity and variety of information, and use a greater variety of methods to acquire and exchange information. The photos on the right side of the slide illustrate some of the information exchange methods humans use, such as pointing, gossip, storytelling, instruction, art, and artifacts. This extreme degree of information acquisition and exchange is one of the traits that distinguishes our species. As Pascal Boyer puts it, one thing that modern humans did and still do vastly more than any other species is exchange information of all kinds. The proper milieu in which humans live is that of information, especially information provided by other humans. It is their ecological niche. Thus, the foraging niche can be thought of as the information niche, and information can be seen as one of the resources exploited by humans. Information is a resource that foragers use to acquire other resources, such as plant and animal foods. The Mythen chapter looks at the different kinds of information or cues hunter-gatherers use to locate and acquire resources, and the kinds of foraging information they exchange with others. Mythen is interested in how hunter-gatherers make foraging decisions. What sorts of information cues do they use? How and when does information exchange take place? How do foragers store and recall information? To answer these questions, he looks at information gathering and processing in 34 hunter-gatherer cultures in diverse habitats. He divides the information cues used by foragers into 8 categories: tracks, excretions, terrain, vegetation, sounds, smells, animals and plants, and weather. We'll look at each of these categories in turn. Following tracks is one of the most obvious and common means of locating prey animals. Tracks may be searched for deliberately, as when tented trappers search for tracks of fur-bearing animals when choosing places to locate their traps, or tracks may be found accidentally. For example, when foragers are pursuing one species, they may come across tracks of a more desirable species and may change their plans and pursue the more desirable animal. As we saw last week, tracks can provide a wealth of information about an animal, its species and sex, age, how fast it's traveling, whether it's alone or with other animals, its physical condition, whether and on what it's been feeding, and the time of day it passed through. Tracks can also be used to assess patch quality, that is, to estimate the general densities of prey and the age structure of prey populations in an area. This information may be used in later decisions, such as when to move on to another patch. From this perspective, the absence of tracks in a region is important information because it indicates that there's little or no game in the area. Like tracks, excretions are widely used to acquire information about resources. The shape, size, weight, quantity, compactness, composition, and dispersal of droppings can all provide useful information, such as species, sex, age, health, recent movement patterns, and recent feeding activity. The latter is useful because if you know what type of plant an animal has been eating, you can look for the animal in places where that plant grows. Like tracks, the information gleaned from droppings can be used to locate the animal or to make estimates of patch quality and decisions about patch use, such as whether to stay or leave. Urine can also provide useful information. For example, moose can be tracked in part by noting where they've urinated, and Warani foragers use urine dripping from the forest canopy to locate potential prey. Another excretion that provides information is blood. The extent of blood flow can indicate how severely an animal is wounded and thus whether continued pursuit is worthwhile. 2 other kinds of environmental cues that provide information about animal resources are terrain and vegetation. Terrain cues include permanent features of the landscape and temporary characteristics resulting from animal activity or plant growth. Permanent features are things such as knolls and streams. The presence of such features may serve as cues to the location of game or how game may react if startled by the hunter. Temporary features are things caused by animal activity or plant growth. Some examples are patches of ground that have been pawed by moose, depressions in the ground where animals have slept, patterns in mud made by burrowing mollusks, and cracks in the ground made by truffles or tubers growing beneath the surface. Similarly, The ways in which vegetation has been affected by animal behavior may provide cues to the location and state of those animals. For example, leaves or bark may have been nibbled and chewed and thus indicate where and when an animal has been feeding and the type of food it's currently eating. Indeed, foragers may look for places where an animal has been feeding while they are tracking it. For example, the coon note which plants have their tips missing in the vicinity of tracks. Other vegetation cues that result from animal movement or behavior are things like broken twigs and turned leaves caused by an animal passing by, foliage that has fallen from an animal's mouth while eating, bark scraped from short bushes by antlers, and scratch marks. The latter cue is used by the tiwi, who locate possums by searching for their scratch marks on tree trunks. Another cue is ground vegetation that's been trampled or disturbed. This cue is used to locate peccary herds, which are easy to track in the Amazon forest because of the disturbance they make in the vegetation of the forest floor. Another type of environmental cue that provides information about animal resources is sound. One source of sound is the movement or behavior of animals. For example, Valley Bisa hunters locate buffalo herds by the noise that they make when they're on the move. Warani hunters locate prey by listening to the sounds of animals moving in the forest canopy, or by listening for the sound of urine dripping from the forest canopy. The Kuchin locate moose using the sound of breaking twigs, antlers brushing against vegetation, or the raking of antlers in the bush when males are fighting each other. Similarly, the Kung listen for the sound of kudu fighting when stalking them. Animals can also be located by their calls. For example, the Kuchin locate moose by the low calls that males make during the breeding season. And buffalo herds can be located by listening for the calls of the predators that follow them. In contrast to sound, smell is of limited use because this sense isn't highly developed in humans. However, scent cues are sometimes used, as when hunters smell paca burros to tell whether they're occupied, or locate howler monkey droppings by their pungent smell, or use the musky odor of moose to locate and track them. Also, some foragers use dogs to hunt, which can be seen as the use of scent cues, since dogs rely heavily on their sense of smell when they hunt. Yet another type of environmental cue that can be used to locate prey is weather. For example, in arid environments, foragers observe where and how much rain falls, and use this information to make inferences about the location and characteristics of resources, and to make decisions about where to move next. Another source of foraging cues is animals and plants. One animal or plant species may provide a cue about itself in the future or about another species. For example, the current movement, both speed and direction, of an animal or herd may indicate where it will be found later. To take another example, the age composition of a herd may indicate the stage it's reached its migration. And, as noted earlier, the number of animals observed or exploited provides information about the richness of a patch. For example, Yakutat fishermen use the number of fish taken as a cue when deciding whether or not to remove their fish traps. Another important source of information is the size and characteristics of an animal. For example, antler size or amount of fatty tissue may be used when deciding which animal to target in a herd. Finally, the presence of one species may indicate the presence or location of another. For example, the Kung find underground bulbs by observing where guinea fowl have been scratching for them, and Valley Bisa watch the warning flights of cattle egrets and oxpeckers to locate buffalo. Similarly, the state of a plant species may indicate the arrival, ripening, or availability of another resource. For example, on Groot Island, the woolly butt and pincushion plants flower at the same time that honey is plentiful in wild bees' nests. The visible part of a plant may provide a cue to the presence of tubers or other edible parts that are difficult to see or not directly visible. A case in point is the wild bean, whose bright flowers enable it to be detected in the scrub forest. The presence or behavior of a species may also provide cues about future weather conditions. For example, the Groot Island islanders use crabs leaving mangrove swamps and termites building mounds as indicators of forthcoming storms. Another important source of information about resources is other humans. Hunter-gatherers constantly use other individuals to acquire foraging information. Information is exchanged both within groups and between groups. Within groups, information is transmitted informally, in the context of relating news and gossip, talking about recent and past hunting trips, and storytelling. For example, men will tell women about plant resources they've seen while hunting, and women will tell men about tracks and animal sign they've seen while gathering. The most important time of day for information exchange is the evening, when people are gathered in camp. The day's news is passed on and past events are recounted. But information exchange also occurs during the day, in the context of gossip and commentary on the day's events. Past events are often related in the form of dramatized personal accounts, that is, stories. Useful foraging information, such as information about animal behavior, gets passed on in the course of relating stories about past hunts and experiences. Information is also exchanged between groups. One opportunity for doing this occurs when bands aggregate periodically for feasting, performance of ritual, courtship, and/or trade. Visiting between bands is also an important means of information exchange, as are chance encounters between hunting or gathering parties from different groups. Between-group exchange enables individuals to learn about the availability, quantity, and quality of resources in other areas, which is useful information to have if resources give out in your own territory. Information exchange is a form of learning. It's one of the ways foragers acquire useful knowledge. Mythen discusses 4 types of learning in forager groups: formal education, storytelling and song, learning from experience, and ritual. While formal education is rare among foragers, learning through storytelling and song is very common. Stories and songs can be seen as accounts of ways in which foraging problems have been solved in the past. Because it's also a form of entertainment, storytelling is a very informal means of teaching and learning. Adults simply relate accounts of their past experiences, while all members of the group listen and enjoy. Another important form of learning in forager societies is learning from one's own experience. This often involves observation and imitation of others. For example, watching how someone makes an arrow and then trying to do the same thing. Also, one way in which some forager children learn about animals is by keeping pets and observing their behavior. The last form of education that Mythen discusses is ritual and initiation. In ritual, and especially initiation, important knowledge is often passed on to initiates. Some people think that the pain and fear associated with ritual may serve to imprint this important knowledge on the mind of the initiate. In forager societies, there are no books, archives, museums, photographs, or digital devices for storing information. A culture's accumulated knowledge must be stored in the minds of its members. It's not surprising, then, that ethnographers frequently report that foragers have an immense amount of stored information and a prodigious memory for detail. This raises a number of questions. What kinds of information are stored? What format or formats is it stored in? Is all information stored in the same format? Or are some kinds of information stored in one format and other kinds of information stored in another? Mythen presents a brief review of what the ethnographic record has to say about these questions. First, he notes that some kinds of information must be updated periodically, such as the availability of game in a resource patch, while other kinds of information rarely or never need to be updated, such as information about permanent features of the landscape or about animal behavior. Animal knowledge appears to be biased toward animals of greatest economic value. For example, among the Gui, the classes of species which are known about in the most detail are those which are important in the subsistence economy. However, several ethnographers have reported a tendency for foragers to accumulate information about the environment beyond what is needed for efficient economic exploitation. This may be a strategy for accumulating a stockpile of information that may turn out to be useful in the future. This brings us to format. Foraging information is often embedded in accounts of past events, that is, in stories, rather than being stored independently. For example, Kung knowledge of animal behavior is maintained in the framework of past hunting episodes. Similarly, when a Nunamiut is faced with a particular situation, such as the tactics to use when killing a caribou, he will recall a past situation with similar characteristics rather than draw on abstracted knowledge of caribou behavior. Since foragers are preliterate and thus do not keep written records, a culture's oral accounts of past events are in effect its record of its history. There's little data on how far into the past information is maintained, but one type of past event that appears to be frequently remembered is times of starvation and hunger. On this point, myth and ritual may be an important means of storing information about environmental fluctuations that occur at intervals longer than an individual lifetime, such as periods of famine. Widely spaced major disruptions such as famine and natural disasters are problematic because when such an event occurs, there might not be any group members alive who experienced the previous one. Thus, there's no one in the group with knowledge of how to cope with the situation. Myth and ritual provide a means of surmounting this problem. Tiwi initiation rites are a case in point. As Mythen explains, the Tiwi initiation rite teaches the proper preparation of a yam that's toxic in its unprepared state and is only eaten in times of famine. Because famines occur at intervals longer than a human lifespan, this information might be lost if it were not preserved in ritual. Art, too, may be used to store foraging information. For example, Aboriginal abstract paintings represent geographical features and the spatial relationships between them. These paintings reference Aboriginal mythology, the Dreamtime, which contains the same information. Collectively, the paintings and stories serve as maps that mark the location of camps, water holes, and important plant and animal resources. The storage and transmission of information in multiple formats is known as redundancy and is believed to boost retention. The Dreamtime stories do double duty by storing foraging information and by serving as a mnemonic device. If you can remember the story, you can access the geographical information. Once information has been gathered, it must be processed, that is, used to make decisions. The reason foragers gather and store information is that information is integral to making effective foraging decisions, such as where to search for game or which game animal to pursue or when to move camp. The better informed an individual is, the better his or her foraging decisions will be. This is important because a poor decision can result in hunger, injury, or death. Cross-culturally, forager decision-making shares the following characteristics: a high degree of information exchange, stored information, and the use of a wide variety of cues. The ethnographic data related to information processing speaks to the amount of information that is processed when making decisions, the extent of planning activities for the future, and the size of the information processing unit. We'll look at each of these in turn. Information processing involves the integration of data from a wide variety of sources. For example, Lee describes how a coon hunter decides whether or not a spoor is worth following. First, he determines how far ahead the animal is using cues such as tracks. If the animal is less than 2 kilometers away, the hunter next considers the extent of vegetation cover and wind direction. If these are favorable to stalking the animal, the hunter then evaluates the speed and activity of the animal. If these are favorable, that is, if the animal is feeding, resting, or moving slowly, the hunter will choose to stalk the animal. If not, he'll look for other game. Decision-making also involves consideration of what might happen in the near future. That is, it involves planning. For example, when the Gui decide where to move next, they not only choose which areas to go to, but also a whole set of contingency plans if their expectations about particular locations are not met. Thus, information processing is nearly continuous, because foragers must constantly monitor and evaluate their environmental conditions and behavioral options. For example, the Cree constantly evaluate the state of their animal populations, and the Gui are constantly integrating new information into their current picture of the environment. Another facet of information processing that Mythen examines is the size of the information processing unit. How many people are involved in the decision-making process? In some cases, decisions are made on an individual basis. Decisions made by leaders are a case in point. A leader, by definition, is a person who makes decisions for the entire group. As we've seen, this is rare in hunter-gatherer societies, but it does occur under certain circumstances. The number of decision makers may also be constrained by context, such as when a man goes hunting alone. In other cases, individual decision-making is a choice. For example, a Selknam adult male assumes responsibility for making his own decisions, and among the Hadza, men decide for themselves when and where to hunt, without coordinating their activities with others. In contrast, Gui hunters discuss their plans carefully with others to avoid mutual interference. Group decisions are usually made by consensus. The group making the decision may vary depending on the customs of the society or on the nature of the decision being made. For example, among the Gui, decisions to move to a new area are made by each individual household, with women taking the principal role. In other cases, decisions may be made by the elders of the group. For example, Tena elders decide on a course of action, to which the chief can only signify his approval. And among Western Desert Aborigines, elders play an important role in the decision-making process. Alternatively, decisions may be made by the adult males of the group. For example, among the Quarareg, adult males retire each evening to their communal house to discuss matters affecting the group as a whole. In the context of cooperative hunting, all members of the hunting party may participate in the decision-making process, as when all members of a whaling crew participate equally in deciding where to land. There is considerable variation across forager cultures in the types of information used and the methods and extent of information exchange. Some of this variation stems from environmental variation. Foragers adopt decision-making processes which are appropriate to the specific problems they face. Mythen breaks environmental variation down into 6 parameters. The first of these is the nature of the physical environment. Ground conditions, such as sand, snow, and vegetation, and also terrain, affect the types of information that are available to a forager. Different sets of physical features present different constraints and opportunities for making inferences about the location and characteristics of particular resources. The second parameter is the types of species present. The particular physical and behavioral characteristics of potential resources will make certain types of information acquisition and processing methods more appropriate than others. For example, finding highly mobile resources requires extensive information gathering, while information storage is more important for stationary resources. The third parameter is the number of species present. As a general rule, the more species there are in a territory, the more information a forager needs to acquire. The fourth parameter is predator-prey and other competitive relationships. For example, if a forager and a predator compete for the same prey species, then monitoring the availability of the prey species may necessitate acquiring information about the density of the predator. Or, if a forager group competes with other animals for a plant resource, monitoring the availability of the plant species may entail monitoring the density of the competitor species. The fifth parameter is spatial variability. The greater the spatial variability, the greater the need to deliberately acquire and exchange information. Since when hunting in one ecological zone, the forager will not come into contact with species that occupy other ecological zones. And finally, the sixth parameter is temporal variability. In general, the greater the temporal variability in resources, the more information one needs to store about which resources are available at what times of year. And this concludes Lecture 9. In the next lecture, we'll look at a system of information exchange specialized for the exploitation of a single resource, caribou.